Hello everyone. So this is Power Systems Lab 2005. This will be the entrance to the lab beside the computer. So if you try to go inside the lab, you will see different sets. What you are allowed to work on, you are allowed to work the set that doesn't have any sign. But if you are seeing something else like this one, you are not allowed to use this set, and then there will be another set here, and nothing there, and another set and so on. So in that lab, we have main circuit breaker. So if you feel that there is anything, we will shut down the power from the lab by using this circuit breaker. And at the same time, we have two different circuit breakers over there. If there is anything, we will shut down the power from some stations here. This is the set that you are going to see on the table during the lab time. What is inside that set? The main power supply, like what you are seeing, and this power supply has AC power 3-phase 208, but it has two different sets of power supply. One is fixed value 208 line to line, or 120 phase, and the current is 15 ampere. And so the second set is variable one AC from 0 to 120 phase voltage, or from 0 to 208 line to line voltage. And also we have two different DC power supplies. The first one is variable one from 0 to 120, and the second one is fixed DC power supply 120 volts. And this is the variac that will adjust the values of the variable AC or the variable EC. Once you connected everything, you will turn this guy on, and the machine will start working based on the power supply value. These guys are loads. Like for example, this guy is resistive loads. Like what you are seeing, it has different values, and all of these resistors are connected in parallel with different values. Just if you would like to have 1200, turn this on. If you would like to have combination of 1200 and 600, you will turn this on, and so on. For the rest, we have three different phases. We can connect them delta or star. This guy is inductive loads. By the same way, we have three phases, and for each phase we have three different values, because we can manage to have two in parallel, or three in parallel, or we can have only one. This is the capacitive loads, and this is a variable resistance again. What we are going to see here, we are going to see the data acquisition system. So this is the data acquisition system that we are going to see in the lab. The data acquisition system is used for measuring the voltage, the current, the power factor. These guys are used as voltmeter. These guys are used as meters. So if I would like to measure the voltage, I would connect this guy in parallel with my branch. If I would like to measure the current, I would connect those in series with my branch. Again, if you would like to use some of the machines that we have different machines here. We have a synchronous machine, which is our machine that we are going to deal with this term. Like what you are seeing, this synchronous machine has three different phases, and this is the exciter for the DC machine, and this is electrodynamometer, and this guy is the DC machine that you are going to study in electromechanics, or some of you studied it in electromechanics. It has series and shunt field, and this guy is representing the armature. This part is representing the synchronizing module that we are going to use for one of our labs. How to connect the machine in synchronous with the grid. So we are connecting the synchronous machine between these three dots, and the grid between these three slots, and then once I reach it to the synchronizing condition, I will turn that on, then I will monitor what is going on. This guy, which in the last part is the line parameter, like what we are going to see for lab number 4, we are using this kit to deal with the 3-phase transmission line parameters. This is phase A, phase B, phase C, and we try to, because this is educational, so we try to make it for different, or divide it into different portions. The first portion, the second portion, so we can use this one, or we can use this, or we can use this part, or we can use this part, and so on. We try to divide it into different portions, and the length for that transmission line is 375 kilometers. We will talk about that in more details for transmission line lengths. If you are in the lab and you did some connections, there are some precautions that you have to keep in your mind. Imagine, for example, that we have connection like that. This connection is not right. Why? Because I have extension like this and I have exposed conductor. I'm not allowed to do that during the lab because I have power. So once you touch this, there will be, problem for you. That's why we are not allowed to have something like that. I have to change this guy and use one whole conductor instead of using any extension. I'm not allowed to use any extension like that. The second thing is I have to pay my attention to tie conductors. Like, for example, if I'm in the lab and I would like to connect that, I'm not allowed to make tie conductor like that because you could lose it easily. So I'm not allowed to have tie conductor. What else? I'm not allowed to have tea or coffee or foods inside the lab. I have to put my bag away, so you can put the bag over there or you can put it behind the table. You have to be careful during that lab or during any lab here in power systems because we are dealing with what you are seeing on 208 volt, which is line-to-line volt. Please don't turn on the switch unless the TA, the technician, or the instructor checked all of your wiring and to be sure that everything is on the right spots. This is what I would like to talk about for today for the introduction to electric power systems lab. And please be careful, don't bring food, don't bring any coffee, try to wear a mask, try to be away 2 meters from your colleague. If you have any question, just raise your hand. I'm here during the lab time and I'll see you for the next lab. Bye for now.